Okay, we want to solve the inequality x squared minus x is greater than 6. Now, people will often try to use the methods of linear equations. They'll get all the x's on one side and then try to divide by something, and that never works, okay? That's because this is a quadratic. It has both an x squared and an x term. Recognizing that this is quadratic, we see that we want to put it into this form. Well, we'll see why we want to put it into this form. It subtracts both 6 from both sides. We get a quadratic expression greater than 0. Okay, in this case, this is a big help, and in any case it will be. So, in this case, it turns out that this expression factors. Now, it's not always going to factor, and even if it does factor, we might not be able to find the factors, but in this case, it's easy to find the factors. So this factors is x minus 3 times x plus 2. So, now we have two numbers, x minus 3 and x plus 2, both greater than 0. If the product of two numbers is greater than 0, then what does that tell you about the two numbers? Well, I believe if you think about it, and think about it before you pause a minute and think about it. If the product of two numbers is greater than 0, then of course it's positive. That means the numbers can't have opposite signs, because if they had opposite signs, their product would be negative. So if they have the same sign, that means either they're both positive or they're both negative. That means that either this and this are both positive or they're both negative. Okay? So, x minus 3 and x plus 2 have to have the same sign. So, either x minus 3 is greater than 0 and x plus 2 is greater than 0, or x minus 3 is less than 0 and x plus 2 is less than 0. Okay, the condition, x minus 3 greater than 0 and x plus 2 greater than 0, leads directly to x is greater than 3 and x is greater than negative 2. And the condition you have here, where they're both less than 0, leads to x less than 3 and x less than negative 2. Now, if x is greater than 3 and greater than negative 2, then x has to be greater than 3. If it's not greater than 3, then this condition is violated. But if it is greater than 3, this condition holds and this condition holds. Another way of looking at it is if x is between negative 2 and 3, then this condition holds, but this condition doesn't. So x greater than negative 2 is not a sufficient condition for both of these to be true. There are numbers greater than negative 2 that are not greater than 3. However, there are no numbers greater than 3 that aren't greater than negative 2. If both of these conditions are to hold, then we conclude that x has to be greater than 3, and as long as x is greater than 3, both will hold. Thinking similarly, x less than 3 and x less than negative 2 is equivalent to just saying x is less than negative 2, because there are numbers between negative 2 and 3 that make this one true, that don't make this one true. So, our logic again is these both have to have the same sign, meaning that we have this set of equations or this set of conditions, meaning that we have this set of conditions which is equivalent to x greater than 3, this set of conditions equivalent to x less than negative 2. Our solution to the inequality is therefore x greater than 3 or x less than negative 2. Now, another way to solve the inequality, which is equivalent to this, is just to graph x squared minus x minus 6 and see where the y values come out greater than 0. So, we could graph x squared minus x minus 6, see where where it's negative, and where it's positive, of course. Okay, well, zeros, of course, let's assume that we know how to graph a quadratic. And one of the easiest ways to graph a quadratic to get the overall behavior is to find the zeros and the axis of symmetry and use those as a basis for graphing. Okay, the zeros are easily found. How do we find the zeros? Well, we either factor and find the zeros as we saw over here. Or we could use the quadratic formula. Okay, if this thing isn't easily factored, we can use the quadratic formula to find the zeros. And if it's not easily factored, we're not going to factor it and follow this reasoning. Okay, so we easily find the zeros if there are any. If there are no zeros, then it's even easier, and I'll let you deal with that case. Because if there are no zeros, then it's either always positive or always negative. Assuming there are zeros, you can easily find them either using the quadratic formula or factoring. And here we find the zeros to be 3 and negative 2. So the axis of symmetry, being halfway between the zeros, is at x equals 1/2. And the vertex, then, we plug in the x equals 1/2 to see what the y value of the vertex would be. And we get 1/2 squared minus 1/2 minus 6, just plugging 1/2 in here. And that comes out negative 25/4, negative 6 1/4. So we can graph this thing. Here are our zeros. Here's our axis of symmetry, and our vertex is on the axis of symmetry, 6 1/4 units below the x-axis. That's a pretty good graph of the function. Now, all we're really interested in, this gives us more information than we need to answer the question or to solve the inequality. Still gives you a picture of what that inequality could mean. Okay, and now we're going to look for the values, the x values that make this greater than 0. Well, y is greater than 0 here, from here on, and from here on in this direction. So where is from here on? That's from x equals 3 on to infinity. And where is from here on in the other direction? That's from negative 2 to negative infinity. So we conclude that y is greater than 0 when x is less than or equal to negative 2, or when x is greater than 3. Now, this method gives us a picture of the graph, which is more information than we need just to solve the inequality. It's valuable because it shows you how the graph is related to the inequality. And that's kind of an important picture. Function's positive here, it's negative here, it's positive here. So the intervals where it's positive, well, we've done those. And it's negative on the interval from negative 2 to 3. Notice that the value of the function can only change sign if it goes through a 0. Okay, this is a nice continuous function, and the only way you can go from positive to negative is to go through the value 0. So here we're positive, 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 here we're negative, and in between being positive and negative, it's 0. Here it's negative, then it's positive, in between being negative and positive, it's 0. So if we simply solve the equation x squared minus x minus 6 equals 0, we find the values of x where the function might change its value, change its sign from negative to positive or positive to negative. So if we do this without knowing any of this and without having done any of this, remember we're just solving the inequality. If we start here without doing any of the rest of the stuff, we get this picture of the x-axis where negative 2 and 3 are zeros. And it might be useful to write in the fact that these are the zeros. Now, what I'm saying is, y cannot change the sign except by going through 0. And that happens only when x is negative 2 or x is 3, which means you could break the x-axis into 3 intervals. One from negative infinity to negative 2, one from 2 to 3, and one from 3 to infinity. Now, in order to determine, and on each interval, the sign of x, whether positive, or sign of y, whether positive or negative, is unchanging. This means that we only need to test one point in each interval to determine whether the function is positive or negative on that interval. Okay, we're going to say then that x squared minus x minus 6 has unchanging sign on each interval, negative infinity, negative 2, 2, 3, 3, infinity. And we can determine the sign for any of these intervals, it turns out. Well, let's think about it. How would we determine whether the sign is positive or negative on a negative infinity, negative 2? Well, there are various ways. I would go back to graphing the function and do all that stuff. You know, the vertex is below the axis, the zeros are on the axis, so etc. But we're not doing that. We're not using the graphing. We're just using the reasoning that we get when we first determine what the zeros are. Okay. What we can do is, since the sign is the same on every point in this interval, we can just pick any one point in the interval. Okay. So, and if the function is positive at that point, then it's positive everywhere on the interval. If it's negative on at that point, it's negative everywhere in the interval. Okay, well, the interval's negative infinity, negative 2. What value of x are we going to choose? Well, you've got a lot of them. Between negative 2 and negative infinity, many, many choices. So what do we choose? Well, let's choose, we can choose x equals negative 3. That would be fine. If x is negative 3, then what do we have? Negative 3 squared is 9. Minus negative 3 would be plus 3. So already we got 12. Clearly subtract 6, it's still positive. That tells us that the function is positive everywhere on this interval. An even easier number actually to choose would be like negative 10. It's going to be even more obvious. So let's choose x equal negative 10. No reason we couldn't have chosen negative 3, and it's easy to evaluate, so there would be nothing wrong with that. But for x equal negative 10, we're not going to have to do much arithmetic at all. You know, 10 squared is 100. Minus negative 10 is plus 10. Minus 6, clearly greater than 0. We don't have to do the arithmetic. We don't have to add it up and find out that this is 104, although we could easily do it. We know that the positives are way bigger than the negatives. That's all we need. So, x squared minus x minus 6 is positive on this interval. Now, what would you do on the interval between negative 2 and 3? What number would you choose between negative 2 and 3 that you could really easily evaluate? Well, the first choice somebody came up with in class was 1. Well, yeah, that would be easy. You'd get 1 minus 6, clearly negative. Okay? The easiest number you could pick in almost any situation like that is 0, and 0 is in the interval, and 0 minus 6 is again clearly negative. So we conclude that the function is negative between negative 2 and 3. Okay, the rest is straightforward. For the interval 3 infinity, we've got to check that. We could choose any point. 10 is a nice round number, easy to square and so forth. X equals 10 yields 100 minus 10 minus 6, which we can easily see is positive, so that x squared minus x minus 6 has to be positive everywhere on the interval from 3 to infinity. And we arrive at our final conclusion, that x squared minus x minus 6 greater than 0 has solution set negative infinity, negative 2, because as we saw here, the expression is positive on this interval negative infinity, negative 2, and 3 infinity because of what we just saw here. Now, this is completely consistent with the solutions that we got using graphing and the solution that we got using factoring. So any one of these three methods works to solve this quadratic inequality. I haven't got the inequality here, but it's x squared minus x minus 6 greater than 0.